students, welcome to physics class. Today we are going to discuss about third equation of motion. Third equation. Third equation of motion. Or velocity distance relation. Velocity distance relation. Or v square minus u square is equal to as. Hi students, once again I am repeating the concept. Today our concept is third equation of motion or velocity distance relation or v square minus u square is equal to 2as. Now go for the derivation. I can derive step by step. Please observe carefully. The rate of change of velocity is called acceleration. Once again I am repeating. The rate of change of velocity is called acceleration. Therefore, acceleration A is equal dv by dt. That is equal dv by ds into ds by dt. Once again my dear students, the acceleration I can write as dy by dt. That is equal this dy by dt I am writing as dv by ds into ds by dt. If ds cancel, we will get dv by dt. That is the previous step, dv by dt. That means the dv by dt I rewrite as dv by ds into ds by dt. But dv by ds into v. The reason is the rate of change of displacement is called velocity. The reason is the rate of change of displacement is called velocity. Therefore, the acceleration A is equal dv by ds into v. Now, the acceleration A is equal v into ds by dt. Consider this is equation number 1. Now, may I write A into V into dV by, V into, it is dV by ds. Once again, the acceleration is equal V into dV by ds. Consider equation number 1. Now, A into, take this one left side, ds is equal V into dV. Consider this is equation number 2. Now, take a straight line. Consider it is initially at t is equal to 0. The initial velocity is u. At the time the displacement is equal to 0. Now take at a particular position. If the time is equal to t, the final velocity is v and the displacement s is equal to s. Now the acceleration acquired by the object during its journey from u to v is a. Now when time t is equal to 0, velocity is equal to u and distance is equal to 0. Now when time t is equal to t, in that case the velocity is equal to v, called as final velocity. Therefore distance is equal to s. Now integrating equation 2 within above limits, within above limits of velocity and distance. Therefore integral 0 to s a into ds is equal to integral u into v into dv. My dear students, here velocity will be differentiated with velocity integrated by upper limit and lower limit with velocity. Here acceleration, it is a constant because here the differentiation is distance. Therefore the integration should be distance, that is initial distance, final distance. But it is acceleration. Therefore these two are different physical quantities. Therefore acceleration becomes constant. Now the distance varies with the initial distance and final distance. Whereas in this case, this is also velocity, this is also velocity, that means small velocity. Integration is also in the form of velocity. Now take A outside and write integral 0 to s ds is equal to integral initial velocity to final velocity v into dv. Now a into what is integral s? Integral s, integral ds is equal to s. Once again, integral ds is equal to s. Now what are the limits? 0 and s. That is equal to, what is integral v dv? V square by 2. Now what are the limits? The limits are u and v. Therefore, what we get? S within the limits 0 to s is equal to, here what is that one? V square by 2. The limits are, lower limit is u, upper limit is v. Now substitute the limits. Therefore, a we are writing as a only, no change. Whereas s, you have to substitute upper limit, that is s. Minus is the condition. In the place of s, substitute 0. Now that is equal to, in the 1 by 2 as 1 by 2 because it is a constant. Now in the place of v square, substitute upper limit, that is v square, minus in the place of v, minus is the condition. In the place of v, substitute u as a u, square as square. Okay, now take this one towards left side. 2a into s minus 0 is equal to v square minus u square. Now 2a s is equal to v square minus u square. My dear students, the required equation is v square minus u square is equal to 2as. This is called third equation of motion. This is equation number 3. This is called third equation of motion, or velocity position relation, velocity distance relation. I hope you understood about third equation of motion. Hi students, in this video we are going to discuss about fourth equation of motion. Fourth equation of motion. Or Snth is equal to u plus a by 2 into 2n minus 1. Once again, Snth is equal to u plus a by 2 into 2n minus 1. Now, I would like to explain point by point. Please observe carefully. The rate of change of displacement The rate of change of displacement is called velocity. Therefore, velocity v is equal ds by dt. Consider equation number 1. Now, ds is equal v into dt. Consider equation number 2. But we know that v is equal u plus at. This is first equation of motion. Consider this is equation number 3. Now, equation 3 in 2. Now substitute equation 3 in 2. Therefore, ds is equal u plus at into dt. Consider this is equation number 4. Whenever we substitute equation number 3 in equation number 2, we will get ds is equal u plus at into dt. Consider this is equation number 4. Now, take straight line initially at a time t is equal to 0 and the object which moved some distance up to t is equal to n. Therefore, the total distance covered by the object is Sn seconds. During its journey, now the object is at this position. Consider here t is equal to n minus 1 second. The time is equal to n minus 1 second. Consider the journey is n minus 1 second from t is equal to 0 to t is equal to n minus 1. Now what is from t is equal to n minus 1 to t is equal to n? That is nth. That is equal to nth second. This is we have to find. Okay? Now go for discussion. Time t is equal to n minus 1 second, comma, distance traveled is equal to n minus 1. If time t is equal to n second, comma, distance traveled is equal to Sn. Once again, if time t is equal to n, the distance traveled is Sn. If time t is equal from 0 to time t is equal to n minus 1, in that case, the distance traveled is Sn minus 1. Now our aim is to find Snth second. Therefore, integrating equation number 4 within the above limits of time and distance we get integral S n minus 1 to S n into ds is equal to integral n minus 1 to n u plus at into dt. Once again, here the time is n minus 1 second and the time is n. Differentiation is t. Here it is the distance ds. The distance is equal to Sn minus 1 distance and Sn distance. Now, what is integral ds? Yes. What are the limits? The limits are S n minus 1 S n, that is equal to, here we have to take it as integral n minus 1 n into u. I am taking this one inside. At the same time, I am taking dt also here. dt plus integral, take this one inside. A t limits are n minus 1 n. Now take this one inside into dt. Once again I am repeating this point. Take this integration and multiply individually u as well as at. At the same time, multiply with dt individually to u as well as at. That means take this one inside, integral n minus 1 into n, upper limit is n into u into dt, plus once again this one, integral n minus 1 n here and at here, and take this one inside, dt here. So this term we are divided individually. Now what we will get? Here S n upper limit, after that lower limit, minus S n minus 1 is equal to, here u is constant, u integral n minus 1 n into dt, because it is time, it is also time, but it is velocity, so velocity should be constant, plus here a integral n minus 1 n t into dt. Please observe carefully. A is acceleration, that means constant, take it outside. And t is a time, dt also time, it is also time, and dt is also time. So we have to integrate this time with respect to time of integration. Therefore, Sn minus 1 is equal to u into t n minus 1 into n plus a into t square by 2 within the limits. What is that one? Lower limit n minus 1, upper limit n. Now Sn minus 1 is equal to u into, substitute upper limit in the place of t, n, minus substitute lower limit in the place of t, that is n minus 1. Now bracket close, plus a into, take 2 outside, 2. Now what we have? T square. Upper limit is n, lower limit is n minus 1. Now that is equal to u into n minus n plus 1 plus a by 2 into, substitute upper limit, that is n square, minus is a condition, and in the place of t substitute n minus 1, square as usual, square. Now that is equal to u, n going to be cancelled, into 1 plus a by 2 into n square minus a minus b whole square, that is a square plus b square minus 2ab, that is equal to u plus a by 2 into n square minus n square, take minus 1, take inside, plus 2n, that is equal to u plus a by 2, n square cancel. We have 2n minus 1. Therefore, Sn minus 1 is equal to u plus a by 2 into 2n minus 1. Consider this is equation number 5, where this one Sn minus 1 is equal to nth is equal to distance traveled in nth second. Therefore, in the place of this one, write nth is equal to u plus a by 2 into 2n minus 1. Consider equation number 6. This is the required fourth equation of motion. My dear students, I hope you understood integration method or calculus method of fourth equation of motion. Thank you very much for watching this video. Thank you.